Okay, we're going to start today with our warm-up problems. So we're on day 3. For our first problem today, we're looking at f of x to start. And what we have here is that f of x equals 20. So this is similar to what we saw yesterday. Let's put this up here. This is similar to what we saw yesterday. I don't have a value for x, so that means that's what I'm trying to find. I'm trying to find what does x equal, okay? I know that my whole function there should simplify to 20. So I'm going to take my function 2x plus 4 and set it equal to 20 so that I can figure out what value of x would give me that, okay? So we are going to solve for x here. I'm going to start by moving that 4 to the other side. So we get 2x equals 16. Then divide both sides by 2. 16 divided by 2 is 8. So if f of x equals 20, that means x was 8. Questions on this first one? Okay, let's take a look at our second problem here. G of x equals 1. So G of x is our table. And again, I don't know the x. I'm trying to figure out what is x equal to. What I do know here is the y. So y is 1. So here's a spot where y is 1. But then if I keep looking at my table, I have another place where y is 1. So this time we're going to have 2 x values that give us a y of 1. So I need to report both of these. So x equals -1 and x equals +1. Okay. You had a question similar to this on your Unit 2 test, and a lot of people gave me one value, but not both. My answer here is both values, since both of those x's would give me the y that I want. And then finally, our h of x question. This says h of -1. So what we have this time is an x value. So x I know is -1. I'm going to go to my graph where x is -1, and then I'm going to follow that to the point on my line, which would be right here. And we talked about this point the other day, so it's already labeled for us. I know that the x is -1, so I want to give the y. The y is 3. Questions for me on the input-output problems? Okay, if you would for me then, flip to the back side. Flip to the back side and let's talk about that domain range problem. So for today, we're going to talk about the domain of h of x. Remember, domain are the x values. So we're going to talk about what x values can I have for h of x. So that's this graph right here. So I want to start with the smallest x value I see. That's going to be my point that's farthest to the left. So that's this guy. That's my point farthest to the left, and it's at 1, 2, 3, -3. So I'm going to start my domain at -3. And I need to decide, do I want a parenthesis or a bracket here? What do I want on the 3 end? Parenthesis or bracket? Okay. As we're sort of thinking about the answer to that question, I want you to think about why we use brackets for the domain in f of x. So we started at -3 for our x values in f of x, and we said this was a bracket because my filled in circle here meant I had a point there. That point was part of my graph, okay? Now I want you to hop back to, I don't know, roughly 100 years ago when you learned about plotting things on a number line. If I asked you in grade school to plot x is greater than -1, you would go to -1, and what would you put there? Your options are a closed circle or an open circle. What would you put at -1? An open circle. Why would you put an open circle there? Yeah. So a closed circle I would use if I had less than or equal to, because the equal to meant that value included. But the open circle means this is my limit, but I can't actually have -1. So you would go to -1, put an open circle, and then shade anything bigger than that, okay? but you didn't actually have -1 as an option there. It had to be bigger than -1. So I want you to think about that same idea as we look at our graph for h of x. I have an open circle there, okay? Here we set a bracket meant I get that value. I have that value for y, or x, sorry, we have that value for x. But what does that open circle mean? Do I have that value? No. So do I want to use a bracket here? No, we want to use a parenthesis. If I see an open circle, I want to use a parenthesis, okay? And then I need my largest value of x. So I need my point farthest to the right, which would be this guy. And that happens when x is 4. So I'm going from -3 to 4, parenthesis or bracket for this guy. That's a bracket, right? Filled in circle means I have that value. I have that point, so we want a bracket there. Okay. Open circle means I need to use a parenthesis. Questions for me on our warm-up problems for today? Okay. I did throw some practice problems, some review problems into an assignment on Delta Math for you. So remember, we have that quiz over this stuff on Friday. If you want a little extra practice, there is an assignment available for you on Delta Math. You can work on a couple problems tonight or tomorrow night, or if you've got a study hall before this class on Friday, that might be a good thing to look at as a refresher or for some extra help and practice before we have that quiz on Friday. Okay. So if you would for me, please hop into your notes packet. And I want to start on page 90 today. Yesterday, we talked about graphing our linear functions using transformations. We also looked at writing those functions based on the transformation work that we did in Unit 2. I just kind of want to wrap that up today. We went basically right up to the bell yesterday. So I wanted to take a look at a couple more ideas on how we can use this transformation stuff, how we can make changes to our function based on maybe changes to a scenario. So on page 90, we're going to start for today, kind of wrapping up that stuff from yesterday. One of the problems that we saw earlier in this unit was a cab. And I believe it was like $2 per mile for the cab, and then there was a boarding fee. So it gives us the original equation from that cab problem that we saw the other day. And then it says that the cab company decided to increase their initial boarding fee to $5. So instead of a $3 boarding fee, they now have a $5 boarding fee. How will that change my function? I used to have a $3 boarding fee. Now it's a $5 boarding fee. Go ahead. Yeah, it's going to change this part. So y equals 2x plus 5 is my new equation. Now, let's say they decided to keep the same boarding fee, but they're going to change their price per mile to $4. Here's our original function. How is this function going to change if we change our price per mile to $4? What will I do to my function? Yeah, this part's going to change. So our function will now be y equals 4x plus 3. For number 15, it says instead of buying a 10-foot tree that grows 1.5 feet per year, which is what is described here, my tree starts at 10 feet and it grows at 1.5 feet a year. I decide that I want to buy a 15-foot tree that grows 0.75 feet per year. So I'm changing both components of this equation. I'm changing the rate and I'm changing that initial amount. So my new function would look like y equals 0.75x, because that's my new rate of growth, plus 15, because that's my new initial height. I want you now to try 16 and 17. Give me that new equation for 16 and 17. Okay, for number 16, it says Sarah's mistaken and actually received a $50 Starbucks gift card. This is based on an example that we saw at the start of our packet. She still plans to buy $5 lattes. How does this function change if her gift card was for $50 instead of for $100? How does my function change? Yeah, y equals negative 5x plus 50 instead of 100. And then for number 17, in a stunning turn of events, Sarah is now using her $50 gift card to buy iced tea for $2.50. So what changes will we make to our original function here? What am I going to do? Yeah, I'm changing that amount I'm spending per drink to $2.50. Still negative because we're subtracting that amount off the gift card. And then again, the gift card is for $50 and not $100. Questions on page 90 for me? Okay, not too bad. Okay, we just need to keep a careful eye on what it is that we're changing. Are we changing a rate or are we changing sort of an initial or starting value? Okay, now for the rest of today, we are going to talk about slope. So we kind of danced around this idea of what is slope, what do we do with it yesterday when we were talking about transforming the steepness, right? When we looked at changing that A value. Today, we are going to just talk about slope, okay? So when we change the steepness of a linear graph, that's slope. That's what that's called, okay? Our sort of default slope for our parent function is 1. If I changed that in any way, if I've maybe flipped it, put a negative in there, made it more steep, made it sort of compressed it, made it less steep, then I've made a change to the slope. So today we're going to talk about slope and mainly how to find the slope, either from a graph or just from 2 points, okay? So slope, we've talked about already, is rise over run, okay? So rise means if I'm going up or down, how far I go up or down, and run refers to how far I go forward. So my up or down movement over my forward movement. I'm always going to phrase run as moving forward, okay? And then up or down for our rise will depend on if our slope is positive or negative. If our slope is positive, we're going to go up. If it's negative, we're going to go down, okay? So that means we can have positive slopes and we can have negative slope. We'll see a couple other options for slopes as well. What I want you to remember when we talk about slope is that we read a graph the same way that we read words on a page, okay? So we read from left to right when we talk about a graph. So if I'm talking about positive slope, that means as I go from left to right, I'm moving up. So this is a positive slope. A negative slope means as I read my graph from left to right, as I move forward on that graph, I'm going down. This would be a negative slope. Okay. So remember, when we talk about is the slope positive or negative, I have to read my graph left to right, just like you read words on a page. So we're going to start by looking at points on a graph. Okay, so we're given some points here for every problem on page 91. We're going to plot those and then look at the slope between those 2 points. So for number 1, I've got -3, 0. So 1, 2, 3, -3, 0. And then I've got -1, 6. So I'm going to find the slope between those 2 points. So remember, as I'm looking to find slope, I'm always reading from left to right. How do I go from the left point to the right point? Okay, always left to right. Now, on the pretest, I saw several of you, when you needed to find the slope of a line, show me that you were counting up and over, okay? And that's exactly what we're going to do here. So the first thing I want to find is how far am I going up or down? So here's our point that's farthest to the left. I want to know how far, in this case, do I need to go up to be on level with this other point. So this would be 1, 2, 3, 4, 5, 6. I'm going up 6. And then I need to run or go forward 1, 2. So my rise is 6, my run is 2. I went up 6 and forward 2. Now, anytime you give me slope, I want it reduced as much as possible. 6 over 2 we can reduce. 6 divided by 2 would give me 3. So I would say that there's a slope of 3 between these 2 points. And since I'm going up from left to right, this would also be a positive slope. Number 2, same idea. I'm going to plot those points and find the slope between them. So I'm starting with -1, -3. So -1, 1, 2, 3. And then 5, -3. 1, 2, 3. So here's my left point. The first thing I want to count is how far do I go up or down. To be level with my next point, I actually don't have to go up or down at all. So my up or down is 0. And then my forward number is 1, 2, 3, 4, 5, 6. So my rise is 0 and my run is 6. Again, I'm going to simplify this. 0 divided by 6, or 0 divided by any number, is just 0. So my slope here is 0. What I'm seeing, if I connect those points, is a horizontal line. All horizontal lines are going to have 0 for their slope, because for a horizontal line, I'm not rising any. If I have a horizontal line, no matter where it's at, my rise number is always going to be 0, which means our slope will always simplify to 0. Number 3, my first point is -2, 1. My second point is 1, -3, 1, 2, 3. Again, we go from left to right. So here's my leftmost point. To be level with my second point, I need to go down 1, 2, 3, 4. Since I'm going down, I'm going to write that as -4. And then I go forward 1, 2, 3. -4 over 3. This won't reduce any. That fraction is as reduced as it can be. When we're talking about slope, I do not want you to change this to a mixed number. So we could also represent -4 thirds as -1 1/3 or -1.33 with that 3 repeating. But remember, when I'm talking about slope, I'm talking about rise and run. And these numbers aren't very helpful for me to be able to see that. If I were to give you a line with a slope as a mixed number or as a decimal, that would be difficult for you to be able to plot that slope. So we're not going to do that. Keep it as a reduced fraction. Improper fractions are okay. So our slope here is -4 thirds. Negative because we have to go down. And if I connect those points, I can see my negative slope there. And then for our final problem on page 91, I'm going from 3, -1. So 1, 2, 3, -1 to 3, 4, 1, 2, 3, 4. Now, this time there is not a left point and a right point because they're lined up on top of each other. So I'm just going to start with the first point I plotted. My rise to get to the next point would be up 1, 2, 3, 4, 5. So 5 over, and now my run is nothing. I don't move forward at all. So we get 5 over 0 here. Similar to what we saw in number 2, because one of my values was 0. But 0 divided by something is not the same as 0 on the bottom of a fraction. 0 divided by something is always going to simplify to 0. 0 on the bottom of a fraction, we describe as undefined. Anytime you have 0 as the bottom for your slope, I want you to tell me that it's undefined. I will take some credit off if you don't tell me undefined here. Okay, that's important. What we have here is a vertical line. Vertical lines will always have undefined slope. Vertical lines will always have undefined slope because that forward motion is always going to be 0. I don't move forward at all for a vertical line. It's just up and down. The vertical lines always have undefined slope. Horizontal lines always have 0 slope. Excuse me. Questions for me so far? Okay, again, on your pretest, I saw a lot of these where people had drawn out where they were counting how far up did I go, how far over did I go, or down, whatever the case may be. If you have points on a graph or you have a line on a graph, counting your slope on the graph is just fine. But if we don't have a graph and we want to find the slope, then sketching a graph on our own is not always going to be our best option, especially if I've got points that are far apart. It can be really difficult to make sure that sketch is accurate and that I've counted all the places that I've moved. So instead, what we need is another way to find slope that doesn't rely on having the graph. Okay, so that's what we're going to talk about next. So we have another way to find the slope between 2 points, and that's using slope formula. Okay, so the idea behind slope is that we're looking at the rise over the run. Rise is the change in y, right? When I talk about rise, I'm talking about up or down. The up or down axis is the y-axis. So I'm looking at how the y changes for rise. And then run is how far I move forward, okay? The side-to-side axis, where I could look at moving forward, that's the x-axis. So I'm looking at the y change over the x change. That's where our slope formula comes from. So slope formula looks like this. You may have seen this before. Y2 minus y1 over x2 minus x1. What we're looking at here is how the y changed over how the x changed. The important thing when we're using slope formula is that, so we've got 2's here and 1's here. What this is telling me is that the important thing for slope formula is that y's are on top, x's are on bottom, and I've lined up the pieces that come from the same point, okay? x1 and y1 are the components of one point. x2 and y2 are the components of my other point. So I have to make sure I line up the numbers that come from the same point, y on top, x on bottom. So for number 5, that's what we're going to do here. I'm going to show you 2 different ways that we can set up number 5. If you are a formula person and you are going to memorize this formula, terrific. What you may find helpful then is to label your points. So my first point, I'm going to call x1, y1, and my second point, I'll call x2, y2. And then I just have to plug these numbers into their spots in the formula. So this would look like y2 minus y1 over x2 minus x1. So if you're a formula and label person, this is what you're looking at. Okay. If you know that trying to memorize slope formula is not going to work as well, but you remember that slope is rise over run, and you can remember y on top, x on bottom, then there's another approach that you can take here. Okay. So I'm going to get rid of these labels for just a second, and I want to show you the other way that we can approach this. So I know I'm going to have y's on top and x's on bottom. Okay. And I know that numbers from the same point need to line up. So here's a point, y on top, x on bottom. I've got the numbers from the same point lined up. Subtract, and then I do the same thing with my second point, y on top, x on bottom. Now, I want you to notice the numbers are backwards in these different slope formulas I've set up. That's okay. Okay, so we're going to simplify these and see that we get the same slope. So for this first guy, 14 minus 10 is 4. Negative 7 minus 8 would be negative 15. I get a slope of negative 4 over 15. For my second guy, 10 minus 14 would be negative 4. On bottom, 8 minus negative 7 minus a negative means we add 8 plus 7 is 15. Negative 4 over 15. I get the same slope. Okay. The important thing is you put the y's on top and the x's on bottom, and that numbers from the same point are lined up. Okay. So let's take a look at number 6. Same idea, we're gonna find the slope. Do I have any people in here who are formula, I wanna label the points people? Okay. So I'm gonna show both setups. I'm gonna do the label the points method second this time, okay? So if you are not a formula label the point person, then here's what we're gonna do. Here's my point. I want y on top, x on bottom. Subtracting on both, and then my second point, y on top, x on bottom. And now simplify. If you like the labels, x1, y1, x2, y2. So I would have -10 minus -4, and then -12 minus -20. I'm going to simplify where I have minus and negative. Remember, that's addition. So -4 plus 10 would be 6. -20 plus 12, that would be -8. 6 over 8, I can simplify to -3/4. If this is the version that you used, -10 plus 4 is -6. -12 plus 20 is 8. -6 over 8 still simplifies to -3/4. We have a couple more to look at. Number 7, same idea. So here's my first point, y on top, x on bottom, subtract, subtract. My second point, y on top, x on bottom. Now I simplify. -20 minus 7 would be -27. 4 minus 4 would be 0. If we have 0 on the bottom, remember that's undefined. So this would be a vertical line. For number 8, here's my first point, y on top, x on bottom, minus, minus. For my second point, y on top, x on bottom. 9 minus 9 is 0. -6 minus 5 is -11. 0 divided by -11, I could simplify to 0. So we would have a horizontal line here. Questions for me on slope formula? Okay. In the sort of space down here on page 92, I've got a couple more problems. I want you to find the slope for these. Find the slope for those 3 points. Anytime we have a quick check or a quiz or a test, I remind you guys that it's always a good idea to show your work. Slope is one of those problems where it's very easy to make a small mistake. I see a lot of sign errors with slope. So please, 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 especially when we have a quiz or a test or a quick check that includes slope, make sure you show your work. Make sure you jot down your setup. It's very easy to forget as you're simplifying that your slope was negative. It's very easy to accidentally tell me that 4 minus 4 is 8 instead of 0. If you show me your setup, then I can see that you had the right idea and you knew what you were doing. If all you give me is a number and it's wrong, then all I know is that you have the wrong answer, okay? So slope is the type of problem where you wanna make sure that you show your work. Okay, let's take a look at these. Let's check our work. So for A, slope between those 2 points. Here's my first point, y on top, x on bottom, minus, minus. Here's my second point, y on top, x on bottom. 6 minus 2 is 4. -1 minus 7 would be -8. Again, make sure you reduce your slope. 4 over 8 would be a half, so I would have -1/2 for my slope. Again, the mistakes I'll see on problems like this is you'll go to reduce and you'll tell me your slope is -2. You made a silly mistake. If you show me your work, I can tell it was a silly mistake. For B, here's my first point, y on top, x on bottom, minus, minus. Here's my second point, y on top, x on bottom. 5 minus 7 is -2. On bottom, 0 minus 2 is also -2. -2 divided by -2 would be 1. So we have a slope of 1 there. And then finally for C, here's my first point, y on top, x on bottom, minus, minus. Second point, y on top, x on bottom, minus the negative. We'll add here on top. So -4 plus 7 is 3. -1 minus 3 would be -4. No reducing I can do there, so I'll leave my slope as -3 over 4. Questions for me on slope for today? Okay, not too bad. Okay. For homework tonight, you have 2 Khan Academy assignments. In one of them, you will find the slope from a graph. In the other, you will find the slope from 2 points like we just did here.